Here's a number nobody talks about enough. 6.3. That's harvest days, not hours, not minutes, actual full working days. That independent PAMI testing showed one machine in this comparison can save you over a full 2-machine harvest season against a competitor combine. And I need you to understand what 6 days means before we go any further. Because if you farm in the Corn Belt, in the plains, anywhere in this country, where October weather is the most unpredictable business partner you've ever had, you already know in your gut that 6 days is not a scheduling convenience. 6 days is the year you got your corn out clean, versus the year you watched a cold front roll in from the northwest on a Thursday afternoon with 600 acres still standing, moisture climbing back up, and nothing you could do but sit in the truck and do the math on what wet corn drying costs are going to do to your margin when you finally get back out there. 6 days is the difference between a year that hurts and a year that breaks you. And in 2026, with corn sitting around $4.20 a bushel and your break-even somewhere north of $5 and input costs that went up nearly 21% on fertilizer alone last year, you do not have the cushion to treat harvest timing as anything other than the most financially critical variable in your entire operation. So when somebody asks me whether they should be looking at the John Deere X9 or the Case IH Axial Flow 9250, I don't start with horsepower ratings, and I don't start with grain tank capacity, and I absolutely don't start with what color looks better sitting in your machine shed. I start with time. Because time during harvest, the actual number of hours per day that your combine is cutting versus sitting, the number of acres you move from standing crop to clean grain per day, the number of days you finish ahead of the next weather event, that is the variable that determines your profit per acre more than any other single factor on your operation. Everything else we're going to talk about today, the rotor design, the cleaning system, the automation, the fuel efficiency, the dealer network, all of it feeds into that one question. Which machine gives you more productive time in the field? And what is that time worth in dollars at the end of October when you're staring at your books? That's the conversation we're having today at Farm Gear Pro. Let's get into it the right way. Before I get into the machines themselves, I want to set the table on what kind of year we're farming into. Because context matters, and I think too many equipment conversations happen in a vacuum disconnected from the actual economic reality of the guys who have to write the check. USDA is projecting corn around $4.20 a bushel for 2026. Your cost to grow 1 acre of corn, seed, fertilizer, chemicals, land rent, fuel, labor, equipment costs, is sitting somewhere close to $917 per acre in a lot of the Corn Belt right now. That is near a record high. Fertilizer alone jumped close to 21% last year because of what's happening with global supply chains and geopolitical pressures on nitrogen and potash markets. Soybeans are giving you a little more breathing room at around $11 a bushel projected. But the input cost pressure doesn't care what the commodity markets are doing. It just keeps climbing. What all of that means practically is that your margin for error on every operational decision you make this year is thinner than it's been in a long time. You cannot afford a combine that runs slow in tough conditions. You cannot afford a machine that sits in a dealer's service bay for 4 days during wheat harvest because a part isn't on the shelf. You cannot afford grain loss rates that would have been acceptable when corn was at $6 but are genuinely damaging at $4.20. Every bushel that hits the ground instead of the tank, every hour your combine isn't cutting, every missed weather window, those aren't inconveniences in 2026. Those are real losses on an operation that may already be farming at or below break-even on corn. That's the environment these two machines are going to be evaluated in today, and that's the right way to do it. The John Deere X9 1100 is the most ambitious combine John Deere has ever built. Full stop. When Deere sat down to design this machine, they weren't trying to make a better version of what they already had. They were trying to answer a specific question, which was how much grain can a single combine move through in a day without sacrificing the sample quality that determines what your elevator actually pays you for it. Their answer was 2 rotors, 2 24-inch rotors working side by side in parallel, each one processing crop simultaneously, together delivering 45% more threshing area and 80% more separating area than the previous generation of Deere designs. That's not a refinement. That's a fundamentally different approach to the problem of moving large volumes of crop through a machine quickly and cleanly. The feeder house on the X9 is 23% wider than what Deere had before, which means the crop mat entering the machine is spread wider and thinner before it ever reaches the rotors, reducing the slug effect that causes grain loss and rotor stress in heavy conditions. In high-yielding corn, and we're talking about 250 bushel per acre ground in central Illinois or southern Iowa, where the crop is so thick that a lesser machine starts bleeding grain out the back before you've even hit your target ground speed. That wider feeder house is the first line of defense against the throughput problems that cost you bushels. The independent PAMI testing I mentioned at the start found that the X9 delivered 28% more harvesting capacity compared to a competitor flagship in tough wheat conditions, with no measurable sacrifice in grain quality. In canola specifically, the X9 captured enough additional crop to represent $3 more per acre of potential revenue compared to the competitor machine. $3 per acre. On a 2,000-acre canola or wheat operation, that is $6,000 worth of grain that would have stayed on the ground or gone out the back of a slower machine instead of going in the bin and getting paid for. That's not a Deere marketing number. That's a third-party research institution measuring actual grain loss in real field conditions. And it's the kind of data point that deserves to sit at the center of your buying decision rather than getting buried under horsepower comparisons. The X9 1100 is powered by a John Deere PowerTech 13.6-liter engine, rated at 603 horsepower with a max power boost that pushes to 690 horsepower when the machine needs it, when you're pushing hard through heavy corn or fighting tough straw, and the machine needs to dig in and keep moving rather than back off. The 20% better fuel efficiency per bushel harvested that Deere claims for the X9 compared to previous designs comes from a combination of the lower RPM belt drive system with larger pulleys and longer belts that reduce parasitic power loss, and the ProDrive XL transmission that uses two efficient motors to improve power transfer at typical harvesting speeds. On a machine running 300 to 400 gallons of diesel a day in heavy conditions, 20% better fuel efficiency per bushel isn't a footnote. It's a check you write differently every single day of a 30-day harvest season. The Dynaflow XL cleaning shoe on the X9 deserves its own conversation because this is genuinely where your bushels either make it to the bin or hit the dirt. And most guys don't spend nearly enough time thinking about cleaning system performance when they're shopping combines. 75 square feet of cleaning area, 36% larger than the previous Deere design, with 85% more airflow. This is the largest cleaning shoe on any production combine currently available. In heavy, high-yield corn, where the volume coming off those dual rotors is enormous, and a lesser cleaning system would start letting material through that should be going in the grain tank, the Dynaflow XL handles it. In the early morning and late evening, harvest windows that most combines struggle with, when dew is heavy, straw is tough, and conditions are borderline. Those are the hours where the X9's cleaning capacity advantage is most pronounced and most financially significant, because those are the hours that other machines are either sitting on the headland or running slower than they should be, and losing bushels they'd have captured in better conditions. The 50-foot residue spread on the X9 matters agronomically too. Properly spread, sized residue breaks down faster over winter, warms soil earlier in spring, and reduces disease pressure from poorly managed crop trash in a way that quietly improves your input efficiency on the following crop, even if it never shows up on any combine spec sheet. Case IH has been making the axial flow for over 50 years. I want you to sit with that number for a second, 50 years, because it means something specific and important when you're evaluating the 9250 against a newer platform like the X9. Case IH didn't just design a combine with a rotor in it. They invented the single-rotor axial flow concept in the 1960s, and they have spent 6 decades refining every detail of how that rotor interacts with crop, air, concave clearance, and threshing speed. The AFX rotor in the 9250 is 30 inches in diameter, the biggest single rotor in the business, and it uses constant pitch impellers that pull crop and air into the rotor simultaneously, making airflow an integral part of the threshing process rather than a separate function that happens downstream. That integrated air design is why Case IH operators consistently report cleaner grain samples coming out of the 9250 than competing machines in dry conditions, and why the rotor handles the transition between crop types with less drama than most competitors. You can run corn one day, soybeans the next, hard red wheat the day after, and the AFX rotor adapts through configuration changes rather than requiring fundamental setup overhauls between crops. The rotor can be fitted with straight bars, spiked rasp bars, or helical kickers, depending on what you're cutting, giving you genuine mechanical flexibility across a mixed crop portfolio that a single rotor design handles more elegantly than a dual rotor system, precisely because there's only one rotor to configure and monitor. That simplicity has a downstream reliability benefit that I think is one of the most underappreciated arguments for the 9250. Fewer moving parts in the threshing and separation system means statistically fewer failure points per operating hour, and on a machine running hard for 30 consecutive days during harvest. Fewer failure points means a higher probability that you finish the season without a catastrophic breakdown that costs you 3 or 4 days you can't get back. The cross-flow fan in the 9250's cleaning system is something Case IH patents and something their engineers genuinely believe is superior to conventional fan designs, and they have a legitimate argument. Air enters the fan from the top, not the sides the way a conventional fan works, creating a vortex effect that Case IH says delivers full, balanced airflow from edge to edge across the entire sieve width, without the dead spots and uneven distribution that can develop with side-entry fan designs at high throughput rates. The self-leveling cleaning system handles up to 12% slope in either direction automatically, which is a bigger deal than it sounds if you're farming anywhere that isn't billiard table flat, rolling terrain in Kansas, the hills of southern Iowa, the variable topography of the upper Midwest where a combine running on a slope without active leveling is leaking grain on the uphill side and overloading the downhill side of the sieve simultaneously. The tri-sweep tailings processor re-threshes and re-cleans material using 3 sets of impellers before it cycles back through the system, which means less grain going through the system twice and more grain captured cleanly on the first pass. And every bushel you capture on the first pass instead of the second or third is a bushel that costs you less machine energy and less time to put in the tank. The 9250 carries a 410-bushel grain tank and unloads at 4.5 bushels per second, which means a full tank empties in a little over 90 seconds, and the quick-folding tool-free grain tank extensions that come standard help manage the capacity gap against larger tank competitors without adding the setup complexity that some extension systems require. Right here, if Farm Gear Pro is giving you the kind of straight equipment analysis that saves you from making a $700,000 mistake, hit that like button right now and subscribe to the channel. We put real work into every breakdown we do, and we do it because farmers deserve honest information from someone who's been in this business long enough to know the difference between what sounds good in a showroom and what actually matters at 10 p.m. during harvest week. Hit subscribe, ring that notification bell, and let's finish this conversation because the most important part is still ahead. The automation conversation on both of these machines is one I take seriously because the labor situation in harvest operations right now is genuinely difficult and getting harder. Finding experienced combine operators, guys who can read a machine, feel when the threshing isn't right, make adjustments on the fly in variable conditions, and stay sharp through a 12-hour shift without losing focus, is one of the most operationally challenging parts of running a large grain harvest in 2026. The good operators are expensive, and everybody's competing for them. The younger guys are willing and eager, but they're learning on machines that cost more than most people's houses, and in conditions where a bad setting for 2 hours can mean thousands of bushels of grain loss that you never get back. Both of these machines have invested heavily in automation specifically to address that reality, to build systems that compensate for variable operator skill and experience without requiring the operator to be an expert to get expert-level results. The X9's Combine Advisor, through the Ultimate Technology Package, simultaneously and automatically adjusts all 5 critical harvest settings: rotor speed, concave clearance, fan speed, sieve clearance, and chaffer clearance, in real time as crop conditions change through the day. Wet straw in the morning when dew is heavy, drying conditions by mid-morning, heavy yield zones in the low ground, lighter crop on the hilltops, tough late-season corn in the afternoon. The machine tracks all of it and adjusts continuously without the operator having to touch a single setting. Predictive ground speed automation uses the machine's own sensors to maintain consistent feed rate through variable crop density, adjusting ground speed automatically so the combine is always running at peak throughput efficiency rather than waiting for the operator to notice a change and react to it. Harvest Lab 3000 on the X9 monitors. Grain moisture, protein, starch, and oil content in real time as grain flows through the machine. And for wheat producers selling on protein premium, Deere's data shows that every percentage point of protein above 11% can represent around 29 cents more per bushel at the elevator. On multiple loads per day across a long harvest season, knowing your protein content in real time and making marketing decisions based on it rather than guessing is the kind of operational intelligence that pays for technology packages many times over. The Case IH AFS Harvest Command System runs in 3 distinct modes: performance, grain quality, and throughput. And the ability to switch between them based on what the operation needs at any given moment is something experienced operators genuinely value, because harvest doesn't look the same every day, or even every hour of the same day. Early in the season, when elevators are paying premiums for high test weight and clean samples, you run quality mode and let the machine prioritize sample integrity over raw speed. 3 weeks in, when you've got a front coming Friday and 400 acres still to cut, you flip to throughput mode and push. The machine adjusts its priorities to match yours rather than forcing you to manually retune every individual setting every time conditions change. AFS Connect gives you full remote telematics, real-time combine performance data, yield maps, grain moisture readings, and machine fault diagnostics accessible from any device with a cell signal, which means your agronomist can pull yield data before you finish the field. Your farm manager can monitor machine performance from across the operation, and your dealer can see a fault code developing and pre-order the part before it becomes a breakdown that costs you days rather than hours. The reliability and dealer support conversation is the one I always have last, but I always have it, because I've seen too many farmers make their combine decision based entirely on spec comparisons and then spend the worst week of their harvest season on the phone with a service coordinator trying to get a technician scheduled, while their machine sits in the shed and their crop stands in the field waiting. The John Deere dealer network in the United States is the deepest and most widely distributed in the agricultural equipment industry. If you're farming anywhere in the Corn Belt, the Southern Plains, the Pacific Northwest, or the Delta, you are almost certainly within a reasonable distance of a John Deere dealer who has X9 experience, X9 parts on the shelf, and X9 technicians who have worked on the platform enough to diagnose problems quickly. JD Link Remote Diagnostics lets your dealer pull fault codes and machine data without being physically present at your combine, which means, in many cases, your dealer can identify the problem and have parts ordered before the service truck has left their parking lot. And in a tight harvest window, that difference between a same-day fix and a 2-day wait for parts is a difference that has a real dollar value you can calculate based on how many acres you cut per day